Hey guys, it's Simon and welcome back to the LibGDX RPG Kotlin tutorial series. We are almost now at the end with this series. There's not a lot that I want to teach you. Our current status is that we already have our entities, we can move our player around, we create those collision objects out of tiled, we also remove those collision objects when they are no longer needed, we introduced box 2D, we can move through other entities, we cannot move through collision objects, and in the last part we also added something that we can now attack, so there is no animation yet, but we can kill now certain objects as well, so at least other entities, with this axis aligned bounding box and with this query in box 2D. And in this part what we want to do now is to introduce a text, because currently we don't really see how much damage we deal to a certain enemy, and that we are going to improve in this part by introducing a floating text, which is also a little bit of a showcase or a base on how you can create user or add user interface stuff to your game. So what I call that, because of my Warcraft 3 mapping times, I call that a so-called floating text. And what is that? So for me, it's simply a text. You can imagine it like a label, or in our case, a number of the damage. And that one will then simply float to a target location. So for example, to the left, right, or bottom, or whatever. And this moving text, I call that a floating text. And what we are now doing, so we don't... So first of all, we would already have a stage for our game. So when we go to our game screen, there very early in our development process, we created that stage, which is related to our game and which has a width and a height by 16 by 9, because there we work with our game or world units, whatever you want to call that. And for the user interface, what I suggest is that you not mix that up with your game coordinates or your game stage in that case. So we want to create a separate one for that. So it's a separate UI stage, which is then working in pixels, because normally the graphics and the user interface stuff should be in pixels, in my opinion. And the advantage to that is that you don't mix those things up. And for example, if you want to develop a new user interface or whatever, then you are not really bound to your game, and you can easily exchange that or replace it because you have that separated. Okay, so the first thing that we are going to do is to rename our current existing stage, and let's call that a game stage. And then let's simply copy and paste that, because now we also want to introduce a UI stage. And there, what I picked for the game for the dimensions is 1280 by, I think 720 is 16 by 9. And I also chose here the extend viewport. In most of my other games, I used here a fit viewport, and also for the game a fit viewport. But in that game, the extend viewport is working just fine. So I also took the same one for the user interface. Then when it comes to that, we also need to remember what we did with our other stage. And for example, one thing is that when our window is resizing, then we need to update the viewport, and there we want to center the camera like before, and we also need to dispose our user interface stage. Then the next thing is that we need this stage in our entity world and in our different systems. And there you can now imagine that would be a problem, because if we do that, so if we now also inject here the UI stage, how would now our dependency injection mechanism know what kind of stage it should inject to a system? So let's start that up. I think it should already throw an error. Let's see. Exactly, so it throws an exception which is called injectable already added exception, and it tells us that there is already one for scene2D stage. So this is how normally the injectable is stored in the background in Flex. So it's simply the class that you pass in here of that object. And now we want to distinguish there, and that is of course also possible, and there you can simply give it a name. So for example, let's call that the user interface stage. So we give it now a name. So now the game stage is still referred to with that one, and we don't need to change our code. And if we want to use the user interface stage for a specific system, then we can inject it by that specific name. We will see that in a moment. We could also, this is what I did on GitHub, I also gave that one a name, and then always explicitly defined what kind of stage I want to use in a specific system. But that is not necessary, and for us in that case now it's easier that we just give the user interface stage a specific name. That should be sufficient. Good, then the next thing, now that we have this user interface stage, we also need to update our render system, because currently we are not doing anything with that. So here at the top we have our normal rendering for our game, so with the tiled map, the entities and so on. And now the user interface, we want to add that on top. So after everything else was rendered, at the end we want to render now our user interface. And here we now need the second stage. First of all, to make it easier, let's rename that again to game stage to make it clear. And now we want to add the second stage to this system, which is the user interface stage. And there you can use in Flex a so-called qualifier. I think, if I remember correctly, it's the same how it's done in a Spring framework. And there say that this is the UI stage. Then it knows, so for that specific stage, it will look for the injectable with the name UI stage. And here we will get the normal one that we had before. And when we have that, then we can simply render that. So with our UI stage, what we now can do, so first of all, as we learned it, we need to apply the viewport, because the UI stage has a different viewport. So we need to apply that first before doing the rendering to have the correct result. Then we act on the delta time, and then we also draw the stage, and that should be already sufficient. So this is all we need to add a user interface stage, a scene2D stage, to our game. Good, then the next thing that we want to do is that we add now this damage text when something takes damage. And we could either add that to the attack system, because there we are dealing the damage, and modify the life component. So as a recap, maybe if you forgot it, let's go to the attack system. And there you see that we update this life component of any entity that we find, and then we increase this take damage amount. That we could already create here now this damage text, or what is in my opinion a better approach, because there could be other sources where you could take damage. Maybe there would be some code for spells, or maybe there are traps on the map, and then in different systems this take damage is then modified. So that's why we go to our LifeSystem, and there is the, let's say, the single source of truth. So here we know if a damage is applied, then this is done here from whatever source it is coming. And now here we simply want to create now this text that we see how much damage an entity took. And there simply, before we reset the damage so that we get the correct amount to it, let's create a new function in here. Let's call it a damage floating text, or just let's call it a floating text, because it's yeah, this is what we are actually creating. And let's call that, or what we pass in here is the take damage amount. So how much damage does the entity take? And we also need to pass in the position. So where should this text be created? And there we pass in from the physics component the size, because this is what we need. And we also the position of our physics component, and also the size of the physics component, to again have the correct information. What is the bottom left corner or the bottom right corner or whatever, so that we have that available from box2d. And currently we don't pass in the physics components here, but let's quickly change that. Just like that, we have it available. Then let's get this information. And also make sure that an entity has that maybe available, or should we just expect it that it has that anyway? Okay, so I just checked. Looks like that I assumed that everything that takes damage here has a physics component. So also to keep it simple, let's do the same. So here just get the physics component of the entity that takes damage here. And now we can pass in here from our physics component, from the body, the position, and also what we added in one of the last parts, the size information of our physics body. And now let's also just create this function. So this is the number that we want to show. Then we have the position, which is a vector 2. And we have the size information, which is also a vector 2. And the position cannot be null. Good, and in here we want to create now again an entity which will be then part of a floating text system. And the entity, what kind of information does it need? So it just needs to know what kind of text should it show. We will solve that via a scene2D label. So similar like we do it with the rendering for normal entities with our image component, where we have this scene2D image. We will now create entities with a label, with a scene2D label. Then we also give it a lifetime, so how long should this text be there before it gets removed. And yeah, I think that's it. Yeah, the start location, of course. So where does this label get created? And also where will it move to, so the target location, let's call it like that. Okay, so first of all, let's create a new component that we call FloatingTextComponent. So what kind of information do we need? We need the location of our text, which is a vector 2. Then we need this life. I called it the lifespan. So how long should the text be alive before it gets removed? So this is a float. Then we have, of course, the current span time, which I just called time, for example. Then we need also a target location. So where should the text be moving to, which is also a vector 2. And finally, we have a label from scene2D, which is simply our text. And that one is a scene2D label. Okay, then similar like we have it with our image, we also need now a component listener to add the label to the stage, in that specific case to the user interface stage, and also remove it when an entity with such a component gets removed, or when an entity loses such a component. So again, we have our companion object, and there we create now our floating text component listener. Okay, then import those two methods. And what our listener needs is again the stage. So again, we want to have the user interface stage. So let's again use the qualifier that we used in the render system. And we want to have our user interface stage for that. Okay, and then it's very simple, I would say, similar to the image. So here we have our user interface stage, and when a component gets removed, then again, like we do it with the image, we remove an actor, and there we remove the label. Let's call it, I called it here text. Let's change that, because text is actually a different scene2D object from what I know. I think it's is it maybe the text button even? Not sure. So let's rename that to label to make it clear. Good, and when a component gets such a label, then, or such a component, when an entity gets such a component, then let's add it to the scene. So we add the label to our scene. And what we also do, we set a certain action. So you also see that now on the actor, because the label is slowly fading out. And that's what we will solve with the scene2D actions, which we have automatically available when we use that, which is great, so that we have an example for that as well. And we will also set a target location for the label. So where should it move to? This is also what we do within that component listener. So first of all, from our component, from our label, there we add a so-called fade out action. So the plus equal is coming from LibKTX. There we have this extension available. And we will also add this fade out, which is coming from the scene2D actions, as you can see it here. And the fade out requires 2 arguments. So the duration over which it should fade out. And then optional, the kind of interpolation that should be used. So our time or duration is the lifespan that we define, so that's the entire duration of our text. And for an interpolation, I think by default, let me quickly check, I think it's just a linear interpolation. Okay, so it's actually null. Okay, no idea what that means. I guess I'm pretty sure that it's then just a normal linear interpolation, but we use a little bit something more exciting. We use here from the interpolation class of LibGDX, we use the power-free out inverse. What does that mean? Nobody knows what that means. So let me quickly open up the documentation. Okay, so LibGDX offers a so-called interpolation class, as we just have seen it, that you can use in certain areas, for example here in that case for the fade out function, so that you can define how a value changes over time. And there they have certain graphics here below that you see how the value changes. So this is always the target value and the source value, and it's always between a time span from 0 to 1 in those graphics. And there you see, for example, a circle means that beginning it's a little bit slow by increasing the value to the target, then it's a little bit faster, and then it's slowly fading out again. So this is how you can imagine that. Or for example, with a bounce, then it slowly goes to the target value, but it bounces to that value over those 4 specific bounces here. And the one that we have chosen is the power-free out inverse, which is, I think, here below somewhere. So here we have power of 3 out inverse. So that one here is that it starts a little bit slow. So our text will at the beginning just slowly fade out, and then at the end of our time span, then it quickly fades out. So then it's simply jumps to the target value and simply will then disappear. But at the beginning, it's a little bit slower. So this is this power-free out inverse. Okay, and then we also want to set now our target. So where should the label move to? And there we have our text target. And that one we simply set. And there it's the location, so where we start from, plus a random number. So on the x coordinate, we just pick a random number, let's say between 1.5 and minus 1.5 and plus 1.5. So this is still those dimensions here are in game coordinates. So it's 1 world unit to the left, 1.5 world units to the left, and 1.5 world units to the right. We convert that very soon to our user interface stage coordinates, which then it will make more sense to you. Just give us a moment. And on the y coordinate, we simply take the y coordinate of where we spawn the text and then just plus 1 additional world unit. And that should be it. So now we remove the label when a component gets removed from an entity, and we also add the label to the stage, set this fade out effect and also the text target when such a component gets added. And now we just need to add that to our entity world. So in our game screen, let's add another component listener of floating text component listener. Good, good. So that should be it for the component part. Now the last thing that we are missing is the floating text system, and of course I think we did not create yet the floating text itself. Okay, so let's do that in here. So here we want to create, of course, now a new entity, and we want to add now our newly created floating text component in here. And here as a starting point, for example, let's take the bottom left corner of our entity, which gets damaged. So here it's let's use the center of our entity. So here we have the position of the entity, the x coordinate, and for the y coordinate, let's move it to the head, so to the top of the entity. So it's the position y plus the size y. So this is the target location. Then how long should this damage text be displayed to a player? Let's take here 1.5 seconds. And the last thing that we want to need to do is to create a label. And there we create a scene2D label, where the first argument is a text sequence. So let's change that here a little bit. So let's make it here a text and a string, because it should be a general function here. So here we then just pass in the text, and then we need 2 additional arguments. So we need a skin, we need the font name, and the color code, or a label style. So what is all of that? We will see then in a moment. Let's quickly change that here. So here our take damage, we round that to an integer, let's say, and then we also convert it to a string. Oh, and sorry, here it's 2 big. So first of all, we need to only take half of the height in box2D to get to that specific corner, and let's start it at the bottom of the entity, so not at the top. Let's start it at the bottom, because the text itself is also a little bit big and is moving towards the target location, so it's better to locate it at the bottom. Okay, so about this second argument here. So here we need to pass in now a label style. Let's call that, I don't know, floating text style. And what is that? So that is now a so-called label style. Let's also define that up here. So here we will have a floating text style, which is a label style. And that one takes in as an argument a font, so what kind of font should be used for the label, and also the color. And what exactly is that? So in Scene2D, any actor, like a text, a button, or in our case a label, has a specific style, so some information how it should be rendered to the screen. And for example, for a label, of course, what kind of font should be used for the text, and what is the color of the text. Or for a button, it could be what is the graphic when a button is pressed, what is the graphic when the button is not pressed, maybe another graphic when you hover over the button with your mouse, and things like that. And all of that is called so-called styles. So there's a label style, there's a text button style, there is a, I don't know, text style, an image style. There are a lot of different styles in Scene2D. And normally you create a so-called skin. So as the name suggests, it's like a, you can imagine it like a simple JSON file or an information or a text file, which contains all the necessary information for your different actors. So you could have in that skin a style for, I don't know, a label for a headline, a label for a normal text, then a normal radio button, a text button, and all this style information bundled together is then a so-called skin. So the skin is then simply a container for all the different styles that you have. But we are not going to introduce here a skin, because it's, in my opinion, too complex and too complicated for that specific use case here. We don't need that. So that's why we simply create here a style ourselves. And with that, so we create a label style and give it a specific font. So let's call that will be the damage font. We come to that in a moment. And the color of our text will be, for example, white. And now this damage font, so there we have a bitmap font, as we saw before. What is that? So before we come to that, let's not forget, so a font is something that needs to be disposed. So here we have our damage font and we dispose it. And what is a bitmap font? So very simple, it's a graphic or a texture, as we learned it already. And this texture is containing all the different characters of a specific font that you have. And when you then render text, then out of that graphic, so out of this texture, we know again the different texture regions for the different letters. So for the capital A, for the normal A, capital B, lower b, and so on. And then when rendering a text, it simply takes out the different regions of the letters that you want to render, and then it renders it. So this is how you can imagine it. So as we already learned with the texture and texture regions, this is, to put it very simple, a bitmap font. And you can create such a font very easily with the so-called Hiero tool from, I don't know if it's really made by LibGDX, but at least from them I know it from the tutorial. So it's a Java tool, as you see it here. There you can simply choose what kind of font you want to use for your bitmap font. Then you have some sample text, so you see below how it will look like. You can apply certain effects to it. So for example, like a shadow, a color, an outline, whatever. And then when you are happy with the result and with the padding and so on, then you can store or save this information in a so-called, I think it's an FNT file. Let's see in a moment. And you also get a graphic out of it. So we will use simply the font that I used on the GitHub project, and I will then just copy and paste it into that project, but just that you see it how that works. So let's I will add the download link to the video description below, so there you can download it. That will give you a runnable Hiero jar, and then you simply start that up. Let's make it big. Then I cannot remember which font I used. It was some free fonts that I found on Google. So there you can always search for fonts and then just enter also free and then check the license if you are allowed to use this font or not. And yeah, with that, there are so many resources out there. You can very quickly find, I think, almost any font that you like, and there's usually always a free font available. But let's take, for example, I don't know, Simpson. Then here you see a sample text, so how would it look like? You can also add, for example, here in German, that is for me sometimes important for the translations. Does it also support the special characters that we have here in our German language? If the font does not have that, you will see here just some square boxes filled out. Then you know, okay, that font does not support it. Then maybe choose a different one. Then you can choose the size of the font, how big it should be. Should it be in bold version, italic version, whatever. This is just for the rendering part here. So I would not suggest to change here anything. So black background color with white text gives you the best contract to see what kind of outcome you get there. And then on the right side, you can apply the different effects. So for example, let's apply a color. And there we want to have, I don't know, a red text, and we also want to have an outline. So let's add also this effect, and the outline should be maybe not black, maybe it should be in blue, and maybe the width is also a little bit smaller, so I don't know, 1.4. And then maybe also some additional padding for our characters, which might help with some rendering issues if we have those. And yeah, like that, for example, we would have now this font that we like to have. It's really super ugly, so don't use that one, but just as an example. And then you can save the bitmap font, so the BM font files. Let's do that. So in our Mystic Woods YouTube project in the assets folder, I don't know, let's store it here. So that would be, for example, our damage font. So there you see already you get an FNT file, but you don't only get the FNT file, you also get a PNG. So there you see, so this is the graphic with the different characters in it. You also see here the special characters that we added for the German language. And this font file now, is it a normal readable file? Yeah, it is. So there you simply see now for every character that you want to render, what is the position, also the width. So again, like this texture and texture region approach, that it knows where to find a specific character and how to render it. So this is how this Hiero tool is working. And I am now simply taking over the font that I used on the GitHub project and copy it in here. Okay, so this is the text that I used on the GitHub project for the damage. So there I used this red color. And I also made a little bit of a transition effect and some outline with a black border and so on. And this is also what we are going to use. So now we can create this bitmap font. And the first argument here is simply a file from our assets folder. And there we can simply say GDX files internal. And there the path is damage.fnt. So this is our font that we are going to load in that LifeSystem here, and with that we can now create those entities here below with the floating text. So this is the basics. So now we already have, so whenever an entity takes damage, we also have now a floating text entity, which would already get rendered as well. So the only thing that we are currently missing is that we remove this entity then over time, and also that the text is then moving over time. But we would already see some text. So let me show you that. So you see here at the bottom left corner, okay, now this entity is dead, I cannot damage it anymore. But on the bottom left corner, we see already the text popping up and also fading away slowly. So this is already working. You might wonder, why is it on the bottom left corner? We come to that now in our next system. But here we see already, so the groundwork, the basis is already working. So the last thing that we need now is a floating text system. To our surprise, we will iterate over entities which have a floating text component. Who would have guessed that? And also it is an iterating system. Good, and in that system we need both of our stages. So we need our game stage and we also need our UI stage. And we need, of course, access to our floating text components. Okay, perfect. So let's start out very simple. So we want to get the floating text component of the entity that we get in here. And the first thing that we are going to check, if the time is greater equal than the lifespan, then we don't need this entity anymore, and also the text we don't need anymore. So remove the entity, and that's it. So that was the easy part. With that, we are already removing now such floating text component entities. And if we don't remove it, then we simply add the delta time to the time. And now we need to do something special, and that one might be complicated when you hear it for the first time. I hope that I explained it well enough. If not, please let me know in the comments and just ask a question. But what we are currently doing, so in our, let's go back to our LifeSystem. So there we create an entity, and the location that we choose is a location in our game world, which of course makes sense because we know the location of the entity that gets damaged, and for that entity we want to show now a text. So it makes sense that we say, okay, the location is that one of our entity, but we are not rendering the label and the text in our game stage. We are rendering actually in our user interface stage, which is normally way bigger and is independent. In our case, again, when you go back to our game screen, we see that our game is 16 by 9, so the entity location could be, for example, 1, 1. But in our user interface, which is way bigger and is working with pixels, this 1, 1 location of the game would be, for example, I don't know, 200 by 200. Maybe that is the correct location in the user interface. But the important part is that we need to convert this coordinate. So we need to have a way to convert a position from our game stage to a position in our user interface stage. So from a player perspective, let me quickly open up the game once more. I think nothing is broken yet. So let's also quickly remove in the debug system all these box2D lines because we don't need them anymore. I think for the time being, we are pretty sure that our game is working properly. So let's disable the debug system for now. Okay, so again, so when we damage now this entity here, then we have the position of our game, which could be, I don't know, maybe 5 by 5 or whatever. And the same screen, so actually the same window here, we have a user interface viewport over that, which is way bigger. So this 1280 by 720. So the location, I don't know, 5 by 5 or whatever I said before, would be in that case really something like 500 by, I don't know, 500 or 300, something like that. So way bigger. So we need to convert that to have the correct coordinate and location of our text. And that's actually the reason why currently we see the text here below, because the position, let's assume it's 5, 5, in our user interface is actually just here. So this is 5 pixels by 5 pixels. That's why the text is shown here and not up here. So we need to convert that. But luckily for us, that is of course already possible in LibGDX. So let's go back to our floating text system. And there we need now 2 vectors again that we can store this temporary information. So we need to convert first of all the text location to user interface coordinates, and also the target where the text is moving to. That one we also need to convert to user interface coordinates. So let's call the first one maybe user interface location, which is a vector 2, and the second one is the user interface target, which is also a vector 2. So the first thing that we are going to do, our user interface location, we set it to the text location of our component. And now we start our conversion. So from our game stage, we call from the viewport the so-called project method and pass in the UI location. So the project, when we look at that, transforms the specified world coordinates to screen coordinates. So whatever coordinate system we have on that viewport, we will get back the screen coordinates. So from our display, in this case our gaming monitor, for example, we get the coordinates on that display. So that is the first part. And now we need to convert the whatever result we get out there. We need to convert it now to the user interface stage coordinates. So there from the UI stage, again the viewport, and now instead of calling project, we need the unproject method. And that one we can also check, transforms the specified screen coordinates to world coordinates. So this is then the correct position in that specific viewport. And this is what we want. So this is the first part, and then let's quickly copy and paste that because we need the same thing for the user interface target, and there we have the text target. Okay, and now just as a quick demonstration, so from the label we are now setting the position, and that would be, for example, now the user interface location X and the user interface location Y. There's again one thing which unfortunately I think it's not mentioned in the documentation, and I complained about that once from what I remember, and then someone told me no, this is correct because in the Java documentation, in the internal comments, it's mentioned. So here we get the Y coordinates from upside down, so it's basically just the wrong way around, so we need to fix that. So whatever we get back here, we need to subtract it from the viewport height. So here we simply have from our user interface stage, from the viewport, we need the world height and subtract this location. So this is something important to know from the, I think it's the unproject method or the project. One of those is twisting around the Y coordinate. So that's why we need to subtract it from there. Otherwise you don't have the correct height of your label. Okay, so with that we should already see now the text at the correct location. Let's see. So let's go here to our slime and let's attack it. Okay, of course still at the bottom because we did not add this system to our entity world. There's always these small things that I forget. So let's do that, and I think it does not really matter. Let's do that after the camera system, for example. So there we add our floating text system. That should be sufficient. So the important part is that before the rendering, we want to have our correct coordinates for the labels. And finally, okay, so slime got removed, I killed it, but now you see, so the text is now in the center of this little blob and little bit of the bottom side. So we have this X and Y coordinate that we specified there, and now we have the position of our text correctly. The last thing that we now want to have is that this text is also moving somewhere. So it's moving towards the text target that we have specified, and there we also use an interpolation. So we have here our UI location, and there we are going to interpolate now towards our target location. The time, so what do we need to pass into the interpolate? So we have the target value, then we have again this alpha value where you might remember it always needs to have a value between 0 and 1. So for our case that would be the time that this text was currently living divided by the lifespan, and just to be safe we say that at most it can be 1. And as an interpolation we use here a different one. The one that I have chosen was this smooth 2 interpolation, and with that piece now also the text is now moving, and we have this damage floating text effect that we wanted to achieve. So let's try it one more time. Let's go to that slime and let's damage it, and now you see how this number is now moving slowly and also fading out to a random location slightly above the entity that gets damaged. So that's one way how you can add such user interface information to your game. And we are really now using, so we are converting again from our world, so game world coordinates, to a user interface coordinate, which is important, so that you remember that you need to distinguish there because it's completely different coordinate systems. Okay, what I don't like here, and I just noticed that we can actually, I think, just write here, because we are using Kotlin, a simple extension function for a vector 2, which gives us this coordinate that we need, that we don't need to copy paste that here. So let me quickly think how we could name that. So from a vector2, we want to have a new method. Let's call that 2 UI coordinate. And there we just take over what we have down there. I think that should be it. Okay, yeah, there maybe let's call that from. Yeah, something like that. So then we can make here a UI location from our text location in that case, and the same thing here below. So from our UI target, like that. Then we can remove that one here as well, and that would be it. Not 100% happy with the naming here, but I think you get the idea. So let's quickly check. That should still work. And that would be it then for this part. So let's see once more. Okay, still working perfectly fine. So now we have at least some indication that we are dealing damage and that things are working. Good, so my plan now for the last couple of parts is now that you have here a little bit of an overview. So in the next part we are going to introduce something very simple. So currently with the chest we cannot do anything. There we simply integrate something that we now can interact with something that you can interact with. So with this chest in our specific example here. And then we are already introducing the player state information, so that finally our player is not just moving around or floating around without doing any animation, that he's finally then really playing an attacking animation when we are attacking, that he's running when we run, that he's standing when he stands still, and things like that. So that is what we are going to introduce. Those are the upcoming 2 parts, and then there are only 2 things left after that. The almost last one is then an audio system, that we also have some music and sound effects in it when our player is then playing the correct animations. And the last part is then the behavior of our slimes, so the AI, that they are also moving around, attacking our player and things like that. So those are the last couple of parts for now that I have planned for this tutorial series. Okay, I hope you enjoyed it. And see you then in the next one. Bye bye.